Hello and welcome back. We're looking at taking standard form quadratics and turning them to vertex form. This is going to be a multi-video lesson. So for this first one, we're just going to multiply a few binomials. In the first case, a plus 3 times a plus 3 also can be written as a plus 3 quantity squared. I'm going to show it using what I call the box method. So you can see a plus 3 on top, a plus 3 on the side. A times a is a squared. A times 3 is 3a. 3 times a is 3a. 3 times 3 is 9. So that could be written as a squared plus 3a plus 3a plus 9. The two middle terms can be combined to 6a. So this is just a squared plus 6a plus 9. In the same way, if we did m plus 7 times m plus 7, right, that would be m squared plus 7m plus 7m plus 49. So that's m squared plus 14m plus 49. Using the same method with a negative, right, we have v times v times v is v squared. V times negative 5 is negative 5v. Also negative 5v, and negative times negative is a positive, so it's 25. We have v squared minus 10v plus 25. Okay, notice the signs in that one. All right, see if you can do the same thing for, say, I don't know, c plus 4 times c plus 4. Go ahead and pause here and try that. Okay, so if you multiply it out, you should get c squared plus 8c plus 16. All right, now if we went the other way and we started back here at the top, a squared plus 6a plus 9, if I said factor that, okay, that would be a plus 3 times a plus 3, or a plus 3 quantity squared, right? This would, m squared plus 14m plus 49 would be m plus 7 quantity squared. Now notice the relationship here, right? The square root of 9 is 3. Also, half of 6 is 3. We can see that relationship holds. The square root of 49 is 7. Half of 14 is 7, right? So that's why this is just c minus 5 quantity squared. If we factor that, see if you can factor a different one. I'm going to give you a different one here. Let's go with d squared plus 12d plus 36. Pause here, see if you can get that factor. Yeah, so that would be d plus 6 quantity squared, okay? Now, sometimes it's not a perfect square, okay? Sometimes we want to put it in this format, but it's not going to be a perfect square. But what we can do is we can make it a perfect square and then sort of fix it at the end. So let's take this one, and let's say that instead of a squared plus 6a plus 9, let's say that we had a squared plus 6a plus 10. Okay, now of course that's not going to be factorable to a perfect square, but what we can do is we can turn it into, this is the same thing as a squared plus 6a plus 9 and then plus 1. So we can factor the first part as a squared plus, whoops, that's not true. Factor the first part as a plus 3 quantity squared and then have this plus 1, right? So that way we have our perfect square in the beginning, and then we just sort of fix it at the end with this plus 1. All right. And another way we could say, let's try a different one. How about if we had, I don't know, g squared plus 16g plus 57. Okay. Right. Well, looking back over here at this one, right? Half of 12 is 6. 6 squared is 36. It works out perfectly. Half of 16 is 8. So we're going to have g plus 8 quantity squared, but 8 times 8 is 64. So that's not going to work out. We want to get to 64. We need to get down to 57 from 64, right? So we have to subtract 7, all right, to get down there. So this is our answer here. I hope that was helpful. We're going to get to a second video very soon.